Hi, I'm Johannes Blobel from the Heinz-Nixdorf Computer Museum in Paderborn, Germany, and this is our ENIAC reconstruction. So what we have here is a simplified module of the accumulator, which was one of the main parts of the complete ENIAC. We have two accumulators in one housing so that we can actually do some calculations with it. It's constructed as following. We have one accumulator here with 5 digits and the second accumulator with 5 digits instead of one with 10 digits. We have our digit tray over which we can transmit numbers. Then we have the control panel with which we can determine what the accumulators will do. So if they will receive or if they will send their number, how often they will do it, and these are the plugs for receiving or sending a number. Down here we also included a constant transmitter where we can set a fixed number and send it over this plug to the accumulators. The sending is triggered by this button and we can reset it with the reset button. Now currently we have a screensaver program running. If we reset it, it's all set to 0, and now I want to show you how to use this machine. We have these cables to transmit numbers. So to transmit a number to the accumulators, we have to connect the send port of the constant transmitter with the receiving ports of the accumulators. So I want to show you how to calculate the Fibonacci numbers using the ENIAC. So we first connect with one cable to the digit tray, and then we connect both accumulators from the digit tray to the receiving port. We configure it to receive a number by toggling the switches. And we say that we want to send a constant by toggling on this switch. The constant I want to send now is just the number 1. So if I press now the send button, the number is transferred to both accumulators. We don't need the constant transmitter anymore. For calculating the Fibonacci numbers, we are just going to transmit the number from one accumulator to the other and then vice versa. And in each step, the number is being added to the previous one. So we don't need the cable for the constant transmitter anymore. We just connect the send port from accumulator 1 and the receive port from accumulator 2, and vice versa. And now we start sending, first from accumulator 1 to accumulator 2. Those adding the number to the second one, and it looks like that. The number here is cycled through the accumulator 10 times. Those at the end, the same number will stay here. And then the 1 which was standing here has been transmitted and added to the second accumulator. Now we just reverse directions. Press the send button again. And so the number is now sent from the second accumulator to the first one. And now we get the Fibonacci numbers. We started with 1, 1, and we have 2, 3, and we can go on. The speed is very low. Of course, in the original ENIAC it was way, way faster, but we wanted the visitors to be able to actually see how the numbers are being transmitted. And also the manual switching was not present in the original ENIAC, but here for simplicity it is done like that. And as you can see, we calculate the Fibonacci numbers with our rebuild.